Now, in this video, we will going to take up one more problem on shafts. The problem number 9. It treats as a solid steel bar of circle cross section has diameter D will be equal to 40 mm. The length L equal to 1.3 meters and shear modulus of elasticity G equals 80 GPa. The bar is subjected to torque T acting at the ends. A. If the torques have the magnitude T equals 340 Newton meter, what is the maximum shear stress induced in the bar? What is the angle of twist between the ends? Point B. If the allowable shear stress is 42 MPa, and the allowable angle of twist is 2.5 degrees. What is the maximum permissible torque? So this is the problem. So the given data is the diameter is 40 mm and the length is 1.3 meters, which is equal to 1300 mm, and capital G, which is equal to 80 GPa, which is 80 into 10 to the power of 3 Newton per mm square. If the torque has the maximum, say first what we need to do is to find out, have the magnitude of torque is 340 Newton per Newton meter. What is the maximum shear stress induced and what is the angle of twist between the ends? Both we need to calculate. So first we are going to take up, within that we will going to take up the maximum shear stress. From the torsional equation, so what he says, the torque is given by T by Jp is equal to tau by R, where Jp will be equal to pi d to the power of 4 by 32 and capital R will be equal to small d by 2. So therefore, when we have this, T will be equal to pi d cube by 16 into tau. The torque is the maximum shear stress tau is given by 16 into T cross multiplication pi into d cube. So substitute the values now. 16 into 340 into 10 to the power of 3 because the torque is maximum of 340 Newton meter. So divided by pi into diameter is given to be 40. So pi into 40 cube. On simplification, you will going to get it as 27.1 Newton per mm square. So this is the maximum shear stress. And also we need to find out what is the angle of twist. From the torsional equation, T by tau will be equal to G by G into theta into L, or T by Jp is equal to G into theta by L. So therefore, theta will be equal to T into L by G into Jp. So angle of twist theta is given by torque is 340 into 10 to the power of 3 into L is 1300 divided by G, 80 into 10 to the power of 3 into pi by 32 into 40 to the power of 4. So on simplification, you will going to get it as 0.0218 radians. Then convert that radians into degrees. To do that, theta will be equal to 0.02198 into 180 by pi. On simplification, you will going to get it as 1.26 degrees. The second case, what is the maximum permissible torque if tau is given to be 42 Newton per mm square and theta is 2.5 degrees. So based on the torsional strength, which will going to be T will be equal to pi d cube by 16 into tau. So you substitute the values of T, which is equal to pi into 40 cube into tau is 42 divided by 16. So which will be equal to 527.8 into 10 to the power of 3 Newton mm. Therefore, the torque is 527.8 Newton meter, converting into meters now. So based on the torsional rigidity criterion, which will be equal to T equals Jp into G into theta by L. So substitute the values now. Jp is pi by 32 into 40 to the power of 4 into G is 80 into 10 to the power of 3 into 2.5 degrees, 2.5 into pi by 180 divided by the length is 1300. So on simplification, the torque what we are going to get it is 674.845 into 10 to the power of 3 Newton mm. But comparing between, so 674.845 Newton meter. So based on the torsional strength and based on the torsional rigidity criterion, if you are comparing the torsional strength, by considering the torsional strength, the torque is lesser, which is 527.8 Newton meter. Whereas by torsional rigidity, you are getting 674.845 Newton meter. The maximum permissible torque is the smaller among the two values. So therefore, the T will be adopting the maximum permissible torque, which T max will be equal to 527.8 Newton meter. So this is how you will be able to analyze and solve this particular problem. Thank you.